Hi there, my name is Stanley Adessis, and today we're going to talk about rapid application development. We're going to learn what it is, how to implement it, benefits, cons, etc. Presentation shouldn't last too long, and you can find the whole thing online. There are links in the description, as well as links to everything you see in this video. Okay, so RAD, otherwise known as Rapid Application Development, is an 80s baby. It is an idea born of frustration from traditional waterfall development methods, and we're going to look a little bit closer at what those look like. So one of the core principles behind RAD itself is that software is more like clay, not steel. And that's a theme that's going to keep popping up repeatedly in this presentation and really in the idea behind software as something far more malleable and far less permanent than the typical engineering projects that the world was used to prior to its arrival, I suppose. So software is unique in that it is transient. So compared to building a bridge, where you kind of really have to know as an engineer, as an architect, what you're building far in advance of actually beginning the building process. And treating software like a traditional project, like a bridge or a building or anything mostly permanent and made of rigid materials, is a little bit backwards, but for a long time, that was kind of the traditional idea. However, some people started to think that if you had to build a bridge in software, you wouldn't have to keep it the way you built it. You wouldn't have to maintain its exact structure. You could change it every day. You could change it a lot. So we're going to take a look at the brief history of how RAD came to be. So in the 70s, development was ramping up, and in the traditional form that it took, that resembled these engineering projects based on a calculated cost in advance and significant planning, these software projects started to resemble them strongly. It was about defining a specification, then working incredibly long to make that specification a reality, and then finally presenting the project to the clients, the end users, the customer. And unfortunately, between the specification process and revealing the final product to the customer, there are a lot of assumptions that are made, and often the user, the final end user of the product, is not satisfied with what they had charted out months in advance, potentially years in advance. And this still happens today. I have a lot of good examples that I could bring up, personal ones, where companies kind of buy into an idea, a software that they need built or that they need upgraded, and the specifications come years in advance of actually seeing the final outcome, and at which point users and clients may realize that what they signed up for is not what they wanted. Even if the project was delivered perfectly to specification, you could be looking at a piece of software that actually doesn't meet their needs, and thus you would go back and be required to refactor as a development team, or make dramatic changes, add features, fix things you didn't know needed to be fixed, etc. So the costs were pretty astronomical and continue to be for a lot of firms. So this process is the waterfall process, and waterfall kind of refers to the last moment. The last moment is the delivery. When the bridge starts to work, when the boat can sail on its maiden voyage, and when the software is finally in the hands of the user that requested it, or the client that purchased it, etc. So waterfall in the sense that it's all falling down on you now, kind of. It also involves the kind of step-by-step process that we were discussing, which is that the spec part falls down into the development part falls down into this part and that part and that part, and then finally it all hits the user. And then in the 80s, Barry Bowman and James Martin recognized something really important, and that software does not have to mimic these traditional rigid material projects because it's so much more malleable. So Barry Bohm is known for the spiral model, and James Martin has his own model that is kind of synonymous with RAD and rapid application development. And you have a couple history points here that kind of lead through the development of RAD over time. So both of these models evolved. And ultimately, from the 80s until the 90s, they kind of powered the idea behind Agile. And a lot of people confuse RAD and Agile. They think they're potentially the same thing, or maybe one is a subset of another, and they're not really sure how to maybe they are the same thing, just two words for the exact same process, but they're not quite. Also, beautiful snow leopard. Just letting you know, they're agile creatures. Let's take a look at RAD versus Agile. It's not as dramatic as this painting would suggest, but I thought that was a beautiful way to transition. So while RAD is more like a methodology, an approach to software development, Agile feels a lot more like a work software philosophy. And we're going to see how these two differ in a moment by kind of like a point-by-point breakdown by going through the Agile Manifesto and comparing it to what RAD believes. So first bullet in the manifesto is that customer satisfaction by early and continuous delivery of valuable software. Now that is absolutely part of RAD. RAD believes in delivering sooner and prototyping rapidly. So they are pretty much agreed with. They agree with each other on that point. And then Agile says that you should welcome changing requirements, even in late development. This is absolutely a key principle of RAD. RAD is a lot about focusing on loose requirements and adjusting them as needed throughout the development cycle. Number 3 would be working software is delivered frequently, weeks rather than months. RAD doesn't really have specific time frames, but the gist of this is kind of synonymous with RAD practices. So I still put an X. I said that they don't match, but they're kind of similar here. Number 4, close daily cooperation between business people and developers. Feedback is definitely part of RAD. If those are the business people that, in fact, you're speaking to, or the client or the end user, whichever. But a specific time frame and frequency is not specified. Agile believes that projects are built around motivated individuals who should be trusted. RAD, on the other hand, doesn't really talk about the makeup of your team. Face-to-face conversations are the best form of communication. RAD doesn't really have an opinion on this, though, of course, that kind of interaction might be inherent in RAD projects, but I'm sure that they can also be done remotely. Working software is the primary measure of progress, and RAD is also focused on working software. Sustainable development, able to maintain a constant pace. And RAD doesn't necessarily argue that a constant pace must be maintained. It's mostly about speed. Go fast, go faster. Whether or not that's constant or accelerating, I believe that's irrelevant. RAD is not as specific on that. Agile wants continuous attention to technical excellence and good design. Now, this sometimes comes into a strong contrast with RAD, because RAD focuses on functionality and user satisfaction. So there's a lot more prototyping that occasionally puts technical excellence on the back burner. Simplicity, the art of maximizing the amount of work not done, is essential. So RAD is not about necessarily reducing work. It's more like a cost reduction and work reduction, but that's inherent in the methodology. It's not the goal of RAD, but because it's rapid, it's kind of a byproduct of that. So it's not like 100% correlation here, or similarity, I would say. It's kind of like a promise of RAD, but not necessarily a guarantee. And Agile says that best architecture requirements and designs emerge from self-organizing teams. RAD does not have an opinion on the team structure. And lastly, the team should reflect on how to become more effective and adjust accordingly. Again, not really something that RAD discusses, not about team makeup, location, pace. A lot of the interpersonal workings of a team are left to the practitioner of RAD. So Agile, I would say, takes several steps beyond the scope of RAD. While Agile dictates the ideal working environment, just short of how many rubber ducks you should have on your desk, the answer is 2. RAD focuses on just the process of building the software and kind of lets you fill the gaps in yourself for everything else. So let's take a closer look at the RAD methodology. These are found both in the spiral model and the RAD model as well. They're very similar. It's just kind of what's different is sort of the structure of their two approaches, but these core steps are in perhaps each and all RAD practices. And the first step is defining these requirements, much like waterfall. However, they're a lot looser and they don't pin so many expectations to the requirements and so many guarantees. It's kind of like a rough list. And of course, RAD wants to confer with clients and business users frequently, such that requirements that were once thought valuable can be reconsidered and new requirements can be added to better reflect what's actually happening with the piece of software. And if it's not suiting the needs that the client originally thought, or if during the process they discovered something far more important than what they had initially planned to achieve. And then the next step is to prototype, the next stage. And it's all about putting something in the client's hands so that they can actually see what's being done. And again, it doesn't really specify how frequently this happens. Each model has its own sort of timeline and step-by-step process, but effectively you build a prototype, you show it to the client. And at this point, you would go over to the next step, which is the feedback. The client has to provide feedback to what you're actually doing. And this is great because you don't have to wait forever to find out whether or not they're going to value the product you're building. So they present this and the feedback is incorporated, and the RAD methodology can flip between these two stages until both client and developer are satisfied. And that might mean potentially cutting off development at a certain point if budgets are getting tight. But ideally, the client is satisfied that no further feedback is required. And then the last part is the delivery, where developers can take time to optimize the prototypes they've built, improve the backend, make it more sustainable, maintainable, etc. And the final product tends to be something that the customer or the client really enjoy because they were involved in the process the entire time. So now it's just about packaging it up and delivering it. Unfortunately, even though all that sounds really great, there are disadvantages to the rapid application development model. And we're going to take a look at that. Here's a tiger because he looks a little grumpy. Could be a she, I'm not sure. And used a leopard before. I figured it's good to stick with the cat theme. So on the one hand, you have this advantage of speed. You're more likely to finish the project on time and to the client's satisfaction. And RAD does this well because you're not wasting any time as a developer building features that the client will ultimately discard. And along the way, if new requirements are discovered, you add them as you go and you prototype them as you go, such that they don't surprise you at the end where it's like, oh, this is okay, but what we actually wanted was a billion other features that we thought of in the past year that you've been developing this product. So we're just going to need you to go back and add those for another 6 months. The opposite, the con to the speed, and these are not necessarily paired off as relevant to one another, but one negative is that RAD doesn't scale as well as more traditional projects. And the reason this is because you potentially have these changing requirements and changing key features, and basically the story, as how I've dictated it here, the story is changing. And if the more people you have, the more difficult it is to change that story rapidly and to get everybody on board. So it's difficult to keep hundreds, thousands of employees on the same page, potentially, if the requirements are constantly changing week to week. There would be a lot of friction in moving that large group of people. On the next page, we have cost versus commitment. So cost, again, we reduce cost because we've increased speed. And how that's happened is simply because we're not spending as much time developing the features that we don't need to develop, and we're not going back and fixing and adding a whole bunch of things that we didn't expect to add because our waterfall approach didn't allow the client to see the product in advance. So the cost should be significantly lower than a traditional waterfall project. However, RAD requires a bigger commitment from both developers and clients. And a client may not be used to conferring with their developer every week or every 2 weeks or even every month. Maybe that's too much. And suddenly there's a lot more meetings and a lot more evaluation than they're used to. So you have to sell the idea that RAD is a benefit in the long run, even though it will seem like a bigger commitment up front and require more of their time. And lastly, we have developer satisfaction versus interface focus. So to me, as a developer, I see RAD as an opportunity to build something somebody actually wants. Whereas in waterfall, I might work in a silo. I've got my team and I'm building my features and I'm building out my product, and I might be proud of it. But the idea that at the end, the client is going to be incredibly frustrated with what I've built at, no fault of my own. It's merely the byproduct of a process that doesn't involve the people who will benefit from my work. I would rather have them let me know what they want and let them feel joy or whatever emotion is appropriate in the context for having built the actual thing that they need, the actual system that they need, the feature that they need, so that when you actually do finally hand it over, you feel great because you did all that work. You don't have to do more work. You delivered exactly what somebody wanted, which is far more satisfying than finding out that you messed up or that they change their mind and you grow bitter and resentful, right? However, negative there is that RAD is so focused on delivering a working front end that sometimes good engineering practices and back end stuff is tacked on, I should say, toward the end after, like during the finalization process. And that may or may not lead to teams shirking their responsibility of making a really robust product for the sake of making one that looks and behaves as the client desires. Okay, so we covered some of the pros and cons there. And we have this slide to take a look at the fact that there are projects very suited for RAD, and there are those that are just not. And some good examples are employee tools, customer portals, and B2C applications can also be built in RAD. Not so good projects are, for now, mission-critical software, flight controls, pacemakers, etc., because you can't really collect user feedback from people who've passed away due to a faulty piece of code in their pacemaker or failing flight controls. Now, these are obviously jokes, bad ones, but you can imagine why having to rapidly iterate a prototype that is a life or death tool or product is not really a suitable thing to do. We're going to take a look at some of the tools that help enable rapid application development. So these are design and prototyping tools. I'm not going to go through all of them, but it's just a quick rundown of what you can use to prototype designs. So you have all these different applications and what type of application you can prototype with them and which operating system they require. Then there's user testing and feedback. These are really critical for recovering feedback remotely. And Envision is one of the tools that's on both the first list and the second list. It lets you get feedback for web and mobile products, and it's the best for clients. But that's basically what this is. You have a whole list of tools that can help you recover feedback from your end user or your client. Obviously, if you can afford to fly out your clients and have them test the tool on site, and if they're willing to do that, then that is a more interpersonal and better experience. But if not, you have these applications that can help you maintain that feedback loop. And then actual tools that rapidly develop applications are listed on this page. And these tools basically help you get through a lot of the bootstrapping process at a much faster pace. They can help not just build prototypes, but actually build working applications really quickly so that you don't have to go through a lot of the traditional development cycle in terms of building the boilerplate base and setting up your servers and choosing frameworks and doing kind of all this stuff. These tools on this list will kind of bundle a lot of that for you and expedite that process drastically. And OutSystems is one of these tools. We are on the list. And we're going to talk just briefly a little bit about how our tool does enable rapid application development. So we have an IDE that brings together the back end, the front end, the design into one location. It's quite powerful. So you control the back end with workflows, you control the front end with widgets, layouts, and reusable elements, custom styling with CSS, custom HTML is possible, custom JavaScript on the front end is possible. But in general, it helps build these layouts that are kind of industry standard very quickly. And you manage both the data model as well. So it makes it really simple to create forms and CRUD operations that work on your data, both internal and external to the platform. And beyond that, OutSystems is a platform for applications. So it hosts, it scales, it releases, it monitors performance. You have user management, you have version controls, and a whole host of other benefits by using these application platforms, because it takes away a lot of the rigging and a lot of that kind of maintenance that so easily falls apart when you have to do everything by hand by yourself. And that's not something that is exclusive to OutSystems, but they happen to do it very well. So that's the presentation. And of course, this is the little pitch at the end. There's a 2-minute demo that'll give you a little bit of a better idea of how OutSystems does enable rapid application development and goes beyond it as well. And there's a link for that in the description. And that's about it. My name is Stanley Dessis. Thank you for listening and watching.